So this is June 23, again, pure 1 for Edexcel paper. Question 9 is a geometric sequences question using a bit of algebra. It tells us these are the first 3 terms of our geometric sequence. We have to show that, I'll write it down, 3k squared minus 62k plus 40 equals 0. Now, if it's the first 3 terms of a geometric is obviously when we multiply by each time. So the common ratio between these 2 terms will be exactly the same as the common ratio between these 2 terms. So it's like, you know, if you're timesing by 3 between these 2, you're going to be timesing by 3 between these 2. So that means if we divide successive terms, that will tell us what the common ratio is. So 12 minus 3k, divided by 3k plus 4, that will be the common ratio, what it's being multiplied by each time. But that will also be the same as the common ratio between these 2 terms, so it should be exactly the same as if we took k plus 16 and we divided by 12 minus 3k. So we can set ourselves up a little equation, which we can now solve. So multiply that over there and that over there. So we get 12 minus 3k squared equals k plus 16 times 3k plus 4. And now we could just multiply out and simplify. I'll quickly do this just to make sure I'm getting the same right answer. 72k plus 144 equals 3k squared. What's that? That is 52k and then 64. Okay, so taking everything over onto one side, we get 6k squared there, we get minus 124k there, and we get 80. Divide by 2, and there we go. We got ourselves an answer. Okay, so that simple idea that divided by that should give you the same as that divided by that for a geometric. Now, for part B, it says firstly, the sequence converges. If it converges, that means the common ratio, whatever our common ratio is, R, let's call it, has got to be less than 1. Got to be between minus 1 and 1. Okay? So if it converges, our common ratio needs to be less than 1, the modulus of it. Now, we've got our equation involving k, so we can solve this. So we've plugged this into our polynomial solver. I haven't done this yet, so let's quickly do this. And get our answer for what k would be. Now, it's a quadratic, so we're going to be expecting two solutions. Trying to talk and put things in at the same time. 3 minus 62. I mean, I should have some professional pride here and actually factorise it, because actually it factorises nicely and I'm just being stupid. But k equals 20 or k equals 2/3. Now it's tempting at this point to go, oh, it must be the 2/3 because the common ratio has got to be less than 1. But k isn't the common ratio. This is the common ratio, or that is the common ratio. Both those 2 things will be equal. So actually the common ratio comes when we put our k into here. So if we put k equals 2/3 into, let's say, this first term, which is a nicer one to use, actually probably this is the one's nicer to use. If I put it into k plus 16, doesn't matter which I use obviously, 12 minus 3k, it's going to be 16 2/3, oops, over 12 minus 2, so 10. So 16 2/3 divided by 10, well, that's 1.6 recurring, 1 2/3. Okay? That is not from minus 1 to 1. So actually, using k equals 2/3 is not the one you want. It's actually when you use k equals 20. And when we use k equals 20 in there, k plus 16 over 12 minus 3k, we get 36 over 12 minus 360, which is 36 over minus 48, which is minus 3/4. That's the one we want. That is where the common ratio is between minus 1 and 1. So we have to say, find the value of k given a reason for your answer. We'd say k equals 20 is our actual answer we're going to be using, because it leads to a common ratio of minus 3/4, which is between minus 1 and 1, and therefore the sequence will converge. Okay. It then says find the value of s to infinity, so the sum to infinity. So that's nice and easy. We can just go, right, we trot out our sum to infinity rule. This is for part C, which is a over 1 minus r. We know what r is. It's minus 3/4, not 20. Minus 3/4 is the actual common ratio. And a is that first term there, 3k plus 4. And if k is 20, 3 times 20 plus 4 gives us 64 over 1 minus 3/4. So that's what, 64 over 7 over 4, which is 256 over 7. And there's our answer.